Hi guys and welcome to this video on parallel lines. My name's MaffsGuru, really good to see you. Thank you very much for joining me. If you haven't already done so, head over to YouTube and subscribe and click like. The likes are so important for the videos. Otherwise, can you tell your mates, tell your teachers? Hopefully the video will be useful. What are we dealing with? Parallel lines. And as usual, I'm going to teach this in my own inimitable style using a word called FUZX. Yes, I wasn't trying to swear, I promise. And any teachers who are watching, I promise. Right. So, first things first, what on earth is a parallel line? Well, you can't have a parallel line because it doesn't make any sense. But you can have parallel lines. And what do I mean by parallel lines? Well, parallel lines are lines that are basically never, ever going to cross. Right? They are those lines there, fingers crossed, if I've drawn them parallel, they'll go to infinity and beyond, and they will never, ever cross. How do we know in a diagram that lines are parallel? That's really important. Well, we actually add a really funky little line like that. So when we have those arrows pointing in the same direction, and they normally point in the same direction, that means they are parallel. Now don't worry because they will try and trick you. Of course, because what's maths? Maths is nothing more than a big fat trick. And how will they try and trick you? Well, sometimes we can actually have two arrowheads, and I'm going to show you an example of that in just a moment. But parallel lines are really funky. So there we go. There's a parallel line. So I'm going to draw. Right, so they are never, ever going to meet. How is this important to me? Well, believe it or not, there is some maths behind parallel lines, which I think is really funky. And for the moment, I'm going to draw all of my parallel lines in exactly the same way, which isn't to say that parallel lines always go that way. They don't. They're all over the place. And you will have already seen them. In fact, let's talk about a shape now. There we go. Ladies and gentlemen, what do we have? We have a square, and it just so happens that there are a pair of parallel lines. And now to give you an example of how we would then use the two arrowheads, it just points to a different set of parallel lines. All right, so ka-ching, there is a object with some parallel lines, all right, that aren't going that way. Now, how does this help me? Well, now I'm going to draw another line through my diagram. Let's call that one there. We're drawing a line. There we go. There is a line through my diagram, and believe it or not, this also has a name. This line here is called the transversal, or transversal, right? It's called a transversal. It's a line that cuts two other lines. They don't have to be parallel, by the way. Even if I have two lines looking like that with a line like that, this one here is still called the transversal. Why do we know this? Because Barry wants us to know this stupid language. Again, I get very frustrated with maths because it's all smoke and mirrors. Once you see through the smoke and mirrors, you're fine, all right? It's all about the language. Now, how does this help? Right. Well, I'm now going to teach you my rules for FUZX. And there will be teachers out there who have literally stopped sleeping because of this. But there are official names that I'll talk about in a moment. So I'm going to draw a set of parallel lines. Now, believe it or not, there are a number of letters in this shape, and I wonder if you can see them. Can you see the F? Can you see a U? Can you see a Z? And can you see an X? Because if you can, they are all there to help us work out angles. That we're just going to work out angles. All right, so first things first, I'm going to deal with the rule that pretty much everyone can see first, and that's the Z rule. And if you look at this diagram here, what do you notice? Oh my goodness, I've got a Z. But be careful, because you also have a backwards Z. Oh, all right, now I'm going to do the more traditional Z here. Why? Because there is a special rule that we have. So when we have a Z, then what I know is that the angle in each of the corners of the Z are the same. So there, the angles are the same. Oh, now there is an official language for this, yes, and they are called alternate angles. All right, I'm going to put the official words. If If you ever see me for any of my other videos, trust me, I will just call it the Z rule. It's just going to be the Z rule, yes? So that is my Z rule. Yay! The next one people tend to be able to find really easily, I will call the X rule, all right? The X rule. Now again, can you see an X? Well, an X is made by two lines crossing, all right? Basically an X. So here, ladies and gentlemen, is an X. Can you see another X? I should Coco. There is another X here. So in that one diagram, there are in fact two X's. Now, what does that mean? Well, if I draw the rule as it is, well, firstly, they are called vertically opposite angles. All right, so vertically opposite angles, and what we know is that this angle here and this angle here, and I'm actually going to put two dots in there, and you'll see why in a moment, are exactly the same, all right? So vertical opposite angles are the same. Lol, all right? Again, it's the English department. But we also notice that there are two other angles that are also the same size because an X has two opposite angles, all right? So if I do that as a square and a square, for example, they are the same as well. Ka-ching. Flipping heck. Now you notice with this one, I may have extended one of the lines to make it a little easier for you, but can you see the F rule? Oh, well, an F is there. Ka-ching! But in fact, there are four Fs in this diagram. Yes, there really are. Can you see them? Well, not all of them face the same way. So that's certainly one of them. Where is the next one? Well, actually, there is a backwards F here, which actually is 7. So we could call it the FUZX 7 rule, but it makes it too long. So there is another F. Can you see another one? Well, I actually have an upside down F here, right, which is really a T, but there's too many letters in this now. And can you see the other upside down one? There we go. Right, so those are my Fs. I'm going to write them out again. So there we go. Now, what is the specific rule we have here? Well, again, what we now know is the angle between each of those are exactly the same. Oh my goodness. Now, these are called corresponding angles. For parallel lines, they are the same. Ka-ching. There's one more rule. So bearing in mind we've got FUZX, F we've done, Z and X we've done, must be the U rule. Can you see a U? Hopefully you can, because there are two of them. And again, one of them is here. See the U? It's on its side. It's really a C, but I'm not putting a C in that word because it'd be very rude, and I'm not doing it. I'm not doing it. You cannot make me. So, and there, ladies and gentlemen, is a backwards U. Oh, I keep deleting two of them. So let's go back. Here we go. Let's deal with this rule here. Now, bearing in mind, we've looked at previous, so the previous one, yeah, corresponding angles were the same. Vertically opposite angles were the same. Angles in the corner, alternate angles are the same. Do you think these are the same? They're really not. Okay, so I tend to draw my rule like this to remind me it's a U. There are my parallel lines. And again, in this situation, we're now looking at the rule of the angles in the corner, right? So first things first, these are called cointerior angles. And what we know is they add to 180 degrees. That one there is really important. It is used so many times in maths, right? It adds to 180 degrees. All the others, they're the same. The angles are the same. But this one, when it's a U, they add to 180 degrees. Now, why is this important to me? Well, believe it or not, it comes in really useful later on in bearings when you get to that in year 9. I don't know if we do it in year 8, can't remember. But basically, that U rule is used a lot, and generally to try and trick you. All right, so let's look at an example. Thank you very much to Cambridge for allowing me to use their examples. They're awesome. All right, so first things first, let's assume that's parallel, even though it blatantly isn't. So it's really important to know which angle they give you. Right, so this angle in the corner is 120 degrees. So this angle here is 120. They want us to find A, B, and C. Now the order of these aren't actually important. Sometimes you may be able to find B before you find A, before you find C, for example, right? And there are lots and lots of different ways of doing this question. So, first things first, let's have a look at finding, I'm actually going to find angle B first. The reason being is I always like the X rule questions. They're great. Is there an X in this diagram? Yes. Whenever two lines cross, we have an X. So can you see that diagram there? And I'll just draw it over here. We've got this and we've got this effectively. We know that this angle here is 120 degrees. Which angle is exactly the same? It's the one that's opposite, and it just so happens to be angle B. So from that one, automatically, I now know B is 120 degrees. So we've got B. Awesome. Now let's have a look at finding angle, what do you reckon? Actually, I'm going to find C next. So I'm going to rub out this B, because sometimes it makes life easier if I write in the angles, 120 degrees. Why would I find angle C? Because I happen to know that I've got a U rule here. Now I know that that looks like an N, but again, if we draw it out, what have we got here? We know this angle here is 120 degrees. Can I find that one there? Well, yes, because I know that cointerior angles add to 180 degrees. So if I now do 180 degrees minus 120 degrees, that gives me 60 degrees, and ka-ching, we now know that angle C is 60 degrees. Now again, notice I'm doing this in a completely random order. Sometimes you have to do it in the order that they give you, other times you just choose whichever works. All right, so now we've got those angles. How can I find A? Well, there is actually an easier way of finding A, but I'm going to use the FUZX rules first. If you remember now, we've got, let's look for an F, because it seems to be the one we haven't actually used at the moment. So there is our F, and what do we notice about the corners of those angles? Well, they are going to be the same. So because I know that this angle here is 120 degrees, I also know that that angle there is 120 degrees. So A is equal to 120 degrees. Now that's actually probably the best way of doing it, but there is another way of doing it. Now we know that angle C, I love saying that because it's the place in Australia. We knew that angle C was equal to 60 degrees. And there is another rule that I just love, and it's one that we don't use very much at all, and that's this one here. What's that? It's a straight line. And what do we know about angles on a straight line? They add up to 180 degrees. So if we look at this, oh my goodness, I'm having real trouble trying to draw straight lines on this. So if I look at this here, we know that that angle there is 60 degrees. Here is my straight line. That must mean that that angle there adds up to 180 degrees, or at least the 60 with that adds up to 180 degrees, which makes that 120 degrees. Ka-ching. Okay, here's another example, again from Cambridge. Thank you very much, Cambridge, where we have a parallelogram. Yes, two sets of parallel lines. How on earth do we find these? Now again, we've got the rules, haven't we? Got the F, the U, the Z, and the X rule. Oh, well actually, because I've got lots of one particular letter in there, I may as well use that one. And can you see which one it is? Well actually, I'm going to use this one here. It's the U rule, all right? So I'm going to use that U rule, which means that if I look at the angles just in that, that's 72 degrees, and that is angle A. So, they add to 180 degrees. So if I do 180 minus the 72 gives me 108 degrees, right? So 108 degrees, that is angle A. How can I find angle B? Well, I'm going to now realize that I have another U. Ha 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 ha! They are trying to trick me. So I now know that that's 72 degrees. I've got this angle here, which is B. Hold on a moment, I've just done that. Because what do we know about those two angles? They add up to 180 degrees. 180 degrees minus the 72 degrees gives me the 108 degrees. And actually, as it turns out, angle A and angle B are exactly the same size. Now, diagrams can be drawn to make it look really, really tricky. And barring my diagram, which looks terrible because my lines aren't straight, but that's fine, we'll get there. Look at the tricks that they can try and do here. Now, first things first, if you can see the fact here that this is a straight line, we know that the 67 degrees, the A, and this angle here must add up to 180 degrees. So that's where my brain is currently going. But how do I find this angle here? Oh, can you see a Z? I always look for the Z's first. So there is a Z, which is rubbish because a moment ago I said look for the X's first. I have a Z. So what do I know about the angle in this corner of the Z and this corner of the Z? They are the same. And ladies and gentlemen, that gives me that that angle there is 61 degrees. And now I can find A. The diagram looked confusing, didn't I? So if I do the 67 plus the 61, now you're probably sitting there going, why on earth do you have a calculator? And why does it look so complicated? Well, this calculator we use in Australia from year 9 and onwards. If you're lucky, you can have it in year 7. But basically, you can use your calculator. I try not to because I prefer pencil and paper methods. But if I wanted to, I'd do 67 plus 61, and out comes 128 degrees. So there's 128 degrees. So that's the angles I have. To find angle A, I'd want to do 180 minus 128. So again, I can do 180 minus 128 gives me the value of 52 degrees. So angle A equals 52 degrees. Now, why am I showing all this working out? Well, basically for an exam, you've got to show working out. Yes, because that's where your marks can come from. You're always advised to show as much working out as you possibly can. Draw a diagram, really, really helpful. Anyway, I'm done. There we go, ladies and gentlemen. There we go. Parallel lines. Done. Tick. If you enjoyed it, do me a favor, like the video, tell people about the channel, MaffsGuru.com. These notes are all downloadable. You can actually download them as PDF, print them off, cut them up, stick them in your maths book, annotate them, do what you need to do. But I'm going to record another video. All right, hopefully I'll see you again soon. Take care. All right, stay safe. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is MaffsGuru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.